This is the second video measuring the cyclotron motion using Apparatus 2. If you haven't seen the first video using Apparatus 1, please watch that for additional details. We will start with the electron beam accelerated using the maximum available accelerating voltage. And we apply clockwise current. And we'll start by finding the minimum amount of current that will give us a full circular path. Okay, looks like that's about 1.2 ampere. And since the ammeter here is indicated at 0.3 ampere increment, we will go by that increment. And I'm rotating the Lorentz tube to make sure that the beam comes back to the source for a circular, not helical path. Okay, this is 1.5 ampere, 1.8 ampere. Please pause the video as needed to make the necessary measurements. Use the rulers in the shot to calibrate the length scale, minding the perspective effect. The circular path is at about halfway point between the two rulers. Okay, and we will check the what happens with the counterclockwise current. The beam bends downward, so we will do the remainder of the measurement only using clockwise current. Okay, and we'll try lower amount of accelerating voltage. We did 150 volts earlier, so we will try the same voltage here. Again, we start by looking for the amount of current that will give you the largest circular path. It looks like we get that at around 0.9 ampere. And making sure that it's a circular, not helical path. (1.2 ampere). Oh, yeah, that was 0.9 ampere. For some reason, I thought I could get circle at 0.6 ampere. So 1.2 again, 1.5, 1.8, 2.1, and 2.4 is the maximum current here as well. Okay, let's see if we can get 100 volt accelerating voltage as before. Okay, I was worried that this might happen. It looks like the beam is not able to escape just before it reaches 100 volts. There is something I can try. So I don't have an explanation why, but if you have some magnetic field applied, sometimes the electrons will be able to come out at lower voltage. Again, I don't have an explanation why. I just noticed that earlier when I was working with these instruments. This is part of doing experimental work. Sometimes instruments have quirks and idiosyncrasies, and the only way to learn it is by playing with them yourself. Okay, it looks like I can't quite get a circle at 0.6 ampere again. I'll leave it here in case you can do something with it, but if you can't, we'll start out with 0.9 ampere. That's 0.9. Yeah. Okay, now it's 0.9, 1.2 ish, yeah, 1.5, 1.8, 2.1, and I don't know if you can see the path there. Um, 2.4 ampere for the maximum current. So that's the same set of measurements we made for the apparatus 1, and I hope this repeated measurement using a completely different apparatus, even a slightly different model, will give you some sense of experimental uncertainty and other measurement errors that may not be visible on a single apparatus. So with that, I will end this here. Please let me know of any questions.